Hi, it's Wayne Smith of Uber Control. During this short video, we're going to be introducing the idea of building analytics and how this can benefit large buildings and building owners in general. During the first section, I'll be discussing the problem of performance decline in buildings, what the traditional methods are, and introducing how building analytics can help with this. First, we'll talk about why buildings decline, or why building performance declines over time. One of the main factors is equipment failure. So the next one is parameter changes. So we've got building alterations and change of usage. Look at the systems that you've got, you identify what's going wrong, you make changes, and then you repeat. And the system that Keith will be demonstrating later will show you how we can use existing data and get that into a regimented automatic system that's doing that for you. The traditional options for carrying out these improvements: preventative maintenance, reactive maintenance, and then the third option traditionally is you have a level of automation. The new way is to let an analytics engine do the heavy lifting. This thing works 24 hours a day. It'll do the work of multiple people. It's the equivalent of having teams of engineers looking at your screen, going through your system, one system at a time, and checking everything continually. It's not practicable, but analytics engine can definitely do that for you. And then some more good news. A lot of the infrastructure exists already. So in large buildings, hospitals, universities, airports, schools, office blocks, the gathering and the storing of information has been around for a long time, and in most systems it will be there already. So the infrastructure for most of this, we're not talking about adding thousands of new sensors in a building, or we're not talking about putting new monitoring on things. A lot of the time it already exists. So during the next section, our guest speaker, Keith LaRose from Capri Analytics, will be discussing some of the great, fantastic functions and benefits of the Capri Analytics package, and we will also be seeing a live demonstration from one of their live sites.
Real-time data systems that are feeding really detailed, specific analytics, telling the operator in the building what's wrong and what to do about it. And you can also have a team approach where the operators, the engineers, the commissioning agent, the controls people, the owner, everyone's involved in the operation of the building. So there's nothing in a BAS that would look at all this together and say, oh, you have an outside air damper leaking. Your occupants wouldn't complain because the system will compensate for that. It'll just reheat or recool the air and deliver the right temperature to the zones. So you're not going to get complaints from occupants. And your operator's not going to know about it, so he's going to just be there happy, everything's great. But the problem is that there's an energy waste, and that could be built into the baseline of the building. So once you've already found all the low-hanging fruit, you've upgraded your lights to LEDs, you've implemented economizers, you've done all that. How do you go about finding that additional, you're already good, let's say, in your building. That's a fairly expensive problem that you would never maybe find until you physically went around and looked at that damper, and even then maybe you wouldn't. We have over 300 rules that look at things like this. We say, hey, if this is supposed to be closed, the delta T here shouldn't be great. The delta T should be fairly small because we're just bringing it from inside the building and recirculating it. So we look at that, we say, is the delta T of this, our default is greater than 2 degrees? And is that greater than 2 degrees for more than a total of 6 hours in a week? So we look every minute, or however often that sample is coming, and we total up the total amount of time in minutes and then hours that delta T is greater than 2 degrees. And if it's in excess of 6 hours, we notify the personnel in the building, okay? So what it kicks up, and I'll show you a live demo of this is an insight notification. So I want to differentiate it from alarms, because the difference between here is that it's confirmed, it's measured, it's validated much more than an alarm would be. So it not only tells you this is what's happening, here's the data for it, this is what you should do about it. So it really takes a lot of that subjectivity. First of all, it discovers the problem, then it takes the subjectivity away from the operator. It says, here's something we recommend you do about it first. So the first thing I get to is my dashboard. So what I've set up here in my personal dashboard is maybe I have several buildings I'm managing as a building operator or energy manager. I can have a list of some of my favorite buildings here on the right hand side. And these eyeballs, if I click on them, they'll bring me directly to one of that building, and I'll show you that in a moment. I also have favorites that I've set up, so I can set up multi-trends, I can set up alarms, etc. that I want to see, and then reports that have recently run. So for instance, if I log in the morning and I want to see all of the set points that are in manual in a particular building, I can click on that and it's going to give me a report in a couple of seconds. So very easy to get that data from me, and I can also download these as a PDF, and these can be emailed to me automatically. So let's say Monday morning, I don't even want to log in, I just want to get a report of all the set points that are in manual in my building. I can come and see that immediately here. So let's say I was coming in here and I wanted to pull open an air handler trend. Right now we're getting 2,086 trends coming up to this building from the Copper Cube. So if I want, I can sort those and I can just type in air handler 1 here in the search. And what I've done now is I filtered it down to 26 entries from air handler 1. And if I want to look at a mixed air temperature, let's say I was going to do this analysis manually of leaking outside air dampers without having the rule already set up for me, I can come and I can click on mixed air temperature, and it loads up a mixed air temperature trend for the past week or so here. And if I want, I can take this and I can drag it back and say, I want to see back to September of 2015. You can see the speed at which that happens. And I say, well, you know what, this mixed air temperature is very high. I can zoom in and I can come right into that particular week now of data that I'm looking at. If I wanted to add a couple of other trends to it, so the analysis rule we're going to do was the return air temperature, and then I wanted to do damper position. I can search for damper here, and I know that that's on device 11,000, so I can type 11,000 in there, and there's my outside air damper for device 11,000. Great. Select that. It's going to replot that data for me with those new trends that I've just added. So as I can go, doesn't matter what building automation management system I have behind the scenes, I can build my own multi-trends on the fly anytime I want. Let's look at my damper position here. What's my delta T here between these two? Oh, I do have a problem, or maybe I don't have a problem. So let's go look and see a couple of default protection diagnostics. So the heating coil is leaking, adding heat to the air while the valve is supposed to be closed. Let's look at that. So on my air handler, it's determined this based on the National Institute of Standards and Technology, NIST APAR rules. So somebody out in the industry, they've got industry standard rules for when things are wrong. It's telling me that my supply air temperature is more than 2 degrees above the mixed air temperature when the heating coil valve is closed during occupied hours. The message that the operator receives in the email is the heating coil valve is leaking, adding heat to the air while the valve is supposed to be closed. And the diagnosis action we have here is check the valve position while the actuator is commanded closed, and check the valve stem actuator for slippage. Okay? So what I can do from here is, in my insights list, first of all, I can subscribe myself up here, or groups of people to different things. So I can say if it's a medium priority fault detection insight, I'd like it to go to John Smith and Bob automatically. Or I can come in here and I can send this out to somebody. So measure the relative performance of something to either its baseline or to where I want it to be. So this is a room temperature, a zone temperature performance KPI report. So we're looking at that specific thing I just showed you, and we're calculating, on this case, we're looking at 59 zones. The average of all 59 is 92% within 1.5 degrees of set point during occupied hours. And then below that, we give you a breakdown of the top and bottom 20 performing. It could be 10 or 5, depending on what you want to prioritize. But there's my bottom 20 performing zones to temperature performance. And you can do airflow and CO2 and whatever else you want to do. But we have a breakdown of HVAC to essential plugs and lights and non-essential plugs and lights. And from here, I can break that into air handling units, air handler unit 1, I can see the supply and exhaust fan energy all the way down to a particular fan if I want to do that. But in this case, we put a CT around the feet, and this whole energy here you see is what the pumps were using. So the blue plus the red was what the pumps were using. And we imported in the performance curve of new pumps. So we had some pumps in mind that we said these are variable speed pumps that you should use. At the same flow rates, those pump curves were imported, and at the same flow rates being demanded by the building, that's what the energy used would be, which is what's blue. So essentially the red is what you would save every month.
In the final section of this video, I'll be talking about the importance of taking action on the insights that we get from building analytics. It's a really important step, and it's a good way to end the video.
So now I'm going to talk a little bit about how we make sure when we've implemented building analytics, we make the most of it. So this section is called maximizing the effect. We need to make sure that we're not just implementing another reporting tool that's going to be blind to people, that's going to send you out beeps and flashes every now and again to say you've got problems. Otherwise, we're no better off. So we need to take action. Performance is increased by continually monitoring continual analysis, continual action, and continual review. We take information from the system, we work out what's wrong, we work out how to make it better, we take the action, very important, we take the action, we make it better, and then we review again to see if there's anything more we improve. And that's how, as an organisation, Uber Control, we know that this trend of performance decline doesn't have to be the case. If we just implement these few simple stages, then we can take the action required to make continual improvements. So in summary, there are many reasons for decline of performance of building systems: equipment failure, alterations, change of usage, parameter changes, that kind of thing. Decline can be reversed. If you are in a building that's deteriorated over time, we know that we can have a positive effect and we can start that upward trend again. We can make sure that the longer you stay in a building, the better it gets, and that's what we're all about. And also, we know that buildings can also be designed to have this built into them, so that at the design stage you build in certain principles that mean all your new buildings, they're not going to deteriorate. It's been thought about from the start and it's been designed into the system. Traditional methods, not great. PPMs and reactive maintenance and some kind of automation, they're not doing the job that people need. And last point, building analytics are definitely the way forward. It's the way that a lot of industries have already gone, and it's certainly the way that the building services industry direction is moving in. And like I said, it's really good to be a part of that. We're really glad to be a part of that, to have fantastic tools. But in general, it's good to see that that's what's happening in the industry.
Thank you very much for watching this video. If you have any questions or you'd like to know more information about building analytics, we'd love to hear from you. So please get in touch with Uber Control. Thank you.